I want to welcome you to our another International Economics and Finance lecture. And today we're going to talk about purchasing power parity, which is one of the main underlying forces behind exchange rates. And in this class, one of our main goals is to establish what determines exchange rates. This one is the force that is considered to be most important in the long run, and this is why we actually gonna start with it. But let's see first what we're gonna do in today's class. First, we're gonna discuss the law of one price, which actually gives rise to the PPP or price purchasing parity paradigm in determining exchange rates. Then we're gonna test it. We're gonna test it extensively, and we're gonna see how actually it works or whether actually it works. Then we're gonna move for a little while to real exchange rates, and finally we're gonna finish with causes of deviations from purchasing power parity. Okay, so let's start with law of one price. Let me read it to you first. Assuming no transportation cost, no tariffs, no fixed investment necessary for arbitrage, and no other impediments to trade between two countries, all prices of all goods in two countries are the same. Look, what do we see here right away is that this definition right away imposes a lot of assumptions, restrictions on where this law of one price can work. And basically, we see no transportation cost, which is obviously impossible because there's always a cost of taking one good to the other. And unless somebody is going to invent teleportation and it's going to be freely available to everyone, transportation cost is something that is going to exist. We can imagine a situation with no tariffs, like in the European Union. Then we've got no fixed investment necessary for arbitrage. This is something I'm going to discuss with you a little bit later. And generally, no impediments to trade whatsoever. Look, in these circumstances, prices of the same goods in two countries should be exactly the same. And look, we can distinguish four different types of law of one price. Absolute law of one price for individual goods or for price indexes. This one we call absolute PPP, absolute purchasing power parity. And then we have relative versions of these laws. Relative law of one price for individual goods and relative law for price index. So again, we will have now relative PPP. So now let's go through all these laws from the simplest one to the most complex one, but actually, as you will see, from the one that is most stringent to the one that is most lenient. Okay, now what do we see over here? This, according to the law of one price, prices of the same goods in two different countries should be the same. So, price of good I in Great Britain, B denotes Great Britain, at time t should be exactly the same as price of the same good I in United States, denoted by A, America, at time t. Okay, but look, we are assuming that there is some I different goods in the economy, and we are now considering each one of them separately. But look, of course, we cannot just put here price in Britain equals to price in the United States. Why? Well, because prices in Great Britain are expressed in pounds. Prices in United States are expressed in United States dollars. So, what do we need to have here? We need to have spot exchange rate. And this is what we've got. Look, we are defining exchange rate here as price in pounds of purchasing $1 at time t. Okay, so now if we know how many pounds we need to pay for $1, then each dollar of a price is translated into pounds, and because of that, the relationship holds. And now, look, if we know that this law of one price holds, this gives us some immediate consequences, immediate conclusions about the relationship between prices and exchange rates. Look, imagine a situation like this. Price of good I in United States go up, price of good B remains at the same level. So look, what is happening over here? This component, so price of good I in Great Britain is constant. Now, if price of good I in United States goes up, then of course to maintain equality, spot exchange rates need to go down. So, look, what does it mean is that now we will have to pay less pounds for $1 for this equality to maintain. In other words, we will see that as a result of price increase in United States, a pound is appreciating. We need to pay less pounds for $1, and dollar is depreciating. We are receiving less pounds for $1. And of course, look, it works exactly the same if prices in Great Britain are actually going up and prices in United States are staying the same. We expect now that S must go up. What does it mean? It means that now we need to pay more for $1. What does it mean? The British pound, is depreciating, while what is the same as dollar appreciating. Okay, so now we've established that if law of absolute price holds, then changes in prices should be transmitted to exchange rates. Right, and look, of course, usually prices are going up and going down at the same time. But we see here that if price in Great Britain is increasing slower than the price in the United States, again, we should expect pound appreciation and dollar depreciation. Okay, but look, this law of one price, absolute version, is very stringent. This is why we can relax it a little bit and move to relative law of one price, still for individual goods. Okay, so look, I hope that you can see. Okay, let's forget about right side of the equation for a second. And let's focus on the left hand side. Look, if I would divide both sides of this equation by PBIT, I would get 1 equal to ST times PAIT divided by PBIT. Right? So this would be equal to 1. And I could substitute this over here. But look, if I would do the very same thing to the values in the previous period, so we are imagining now that here we have subscript t minus 1, we would also get 1. 1 equals 1, so both sides must be equal to one another. And look, from this we get very important thing. It means that absolute law of one price immediately implies relative law of one price. And it's not true in the opposite direction. We could have here, we can still have this law fulfilled even though an absolute version of it will not be holding. And look, what do we what do we added over here are simply prices of goods in Great Britain and United States in the previous period, and of course spot exchange rate in the previous period. Rest remains the same. So look, here we see that those relative prices, uh, because again, remember those are all prices. Now we were expressing expressing their in relative terms must be equal to one another. This actually shows that up in absolute terms, those prices can actually deviate from the law of one price, and but in the relative terms they should still hold. So the changes, appropriate changes over here, should always compensate in such a way that the relative prices intertemporally, so in between two different time periods, stay the same. And look, as I said before, I hope you can see that this equation clearly implies this equation, but this equation number two is not implying equation number one. Merely equation number one is a special case of this equation. But actually, what we wanted to do is to go a little bit more general. Now, but look, if we would have to do a comparison for all possible prices in the economy, of course, we could establish some system of simultaneous equations for which we could solve it, but it would be extremely troublesome task, especially that we've got thousands, if not millions, of different goods in the economy, right? So if even if it was possible, it would be definitely troublesome to establish relationship based on prices of individual goods. So what can we do? Look, it's like with when we calculate inflation in macroeconomics. Before we do so, we need to create a price index. And price index is basically what stands behind absolute law of one price for now for price index. We're going to call it absolute PPP, purchasing power parity. Okay, so look, what do we have over here? Price index in in United States at time t is equal to sum for all n goods times of expressions of prices of all goods times their weights. Now, those weights, of course, must be between 0 and 1. Of course, AI would be lower. It would be equal to 1 if we would have only one good in the economy, and 0 if 0 would be the case if some good is not included in the index, and of course all those weights must sum up to 1. And now here we shouldn't have this this I. I'm sorry, I'm gonna fix it right away. Now look, we could do exactly the same thing for Great Britain, right? Here also we shouldn't have I. So this is a price index for all the goods in Great Britain, right? Like the same formula. And look, because of the absolute law of one price, I can substitute this for individual goods in the sum symbol. So instead of that, from our initial equation, I can make the substitution over here. And because exchange rate is the same for all the goods, and I will get an expression over here. I can take it out of the sum symbol and I get an expression for price index in the United States. Of course, look, here is one hidden assumption that all those weights in both countries are the same. And as we will discuss it later, it doesn't need to be the case. Look, people in different countries purchase different goods because of cultural differences, because of the structure of income in those countries, and for several other reasons. This is why those weights of different goods in United States, in Great Britain, in Poland, in Germany, Ukraine, in any country doesn't need to be the same, and it's never exactly is. But this, we need to maintain this assumption to, of course, maintain the absolute law of one price for price index. And we will talk about relaxing this assumption right at the very end. Okay, so now we've established again link between price index in Great Britain and price index in United States. Of course, again through exchange rate. And look, from that we get the same conclusions that we got from the first one, but now in more general terms. That if prices on average, so if price index is increasing in Great Britain, while is maintaining at the same level in United States, as need to go up. So we need to pay more for one American dollar. Okay, so look, let's summarize what we said from now. We've got absolute law of one price for individual goods. All right. Now we see that there are some immediate connections between prices and exchange rates stemming just from this equation, and we see that it also holds for price indices in exactly the same way. So now let's relax our law even more. But for that, I need to introduce one additional thing. Look, from this moment on, every time when you see lowercase variable, it will denote natural logarithm of uppercase variable. Look, using logarithms is extremely efficient and convenient in terms of macroeconomic variables, especially that difference in logarithms is approximately equal to growth rate of x. Okay, so now let's go back to the relative law of one price. Absolute law of one price for price indexes. So what do we see over here? Like, this is the repetition of the equation 4, right? Now, if I'm going to multiply both sides, divide both sides by PAT, I will get price index in Britain divided by price index in United States is equal to exchange rate. Now, what I can do is to logarithmize both sides. And look, here I will get logarithm of exchange rates, and here, using the rule that logarithm of a quotient is equal to the difference of the logarithms, I'm obtaining that that logarithm of exchange rate is equal to the difference between price levels in two countries. And look, I could again write the same equation, just putting t minus 1 over here, t minus 1 over here, t minus 1 over here. And then I could subtract the second equation from the first one, and this is what I would get. Look, what do we see here? Growth rate of exchange rate is equal to the difference between inflation in Britain and inflation in the United States. Again, as you see, we got this law, we got our relative law for price index that you see in the equation 8 and in equation 9, that directly from the absolute law. But we cannot go we cannot go in the opposite direction. Remember, again, number 5 is a special case of 8. We get from 5 to 8, but we cannot get from 8 to 5. Okay, so now that we understand the connection between exchange rate and the price levels, I think we can finally put all of those versions of the laws in order. So look, we start with absolute law of one price for individual goods. And look, directly from this law, we can derive absolute PPP, so absolute law of one price for price index. Again, I can also derive relative law of one price for individual goods from absolute law of one price for individual goods. And now, from each of these two laws, I can get relative PPP, relative law of one price. But look, these implications goes in one direction, because here we go from more to less stringent law. And we should remember that going in the opposite direction, we only get a special case of what is before. Okay, so now I hope you can see how the law of one price works. Now let's go to checking if it actually works. And we're going to start actually with the example from your book. And this example goes like this. Of course, first, we're going to be checking only relative version of the law. So look, here the author performed very clever and simple experiment. He took the data for 64 different countries, and what did he do? Is that he calculated change in exchange rate between year 1960 and 2009. Look, all those exchange rates are against the United States. It doesn't really matter which country we choose, but usually in all databases, exchange rates are shown for against one specific currency, but of course we can get from there we can get to any other pair of currencies, but for convenience let's leave it like this. Okay, and what did we have over here? So look, here we see change in exchange rate between 1960 and 2009. Look, it's 50 years, right? So actually we are going to check whether purchasing power parity holds in a relative version holds after 50 years. And as I mentioned before, the purchasing power parity is a long run force behind exchange rates. But this is even, but I hope you can see that this is a very extreme case. Like, if it doesn't work after 50 years, we should definitely throw it away right away. So, in this case, we are allowing a lot of time to spend until everything in the economies adjust in a specific way. And look, we've got what over here. Look, this is merely, I stated differently the equation we've got over here. Here we've got change in exchange rate, growth rate, because those are logarithms. And here is the change in country, in the price level in country I. So inflation over 50 years. And here minus inflation in United States. So our reference country. And I hope you all of that you have over here. J simply is index for a country. And look, now when we want to estimate this equation, look, I didn't add disturbance term, but of course this was estimated using OLS. In this is and look, what is very important here to notice, look, there's no time subscript because we've just calculated differences between two time periods. So this is actually cross-sectional estimation, which it makes it very convenient because we don't need to care about spurious regression, co-integration, and stationarity issues that are for now a little bit beyond our scope of interest. Okay, so what do we see over here? Look, this model is a theoretical model. But look, if we are estimating a linear equation with OLS, how will we estimate it? Well, on the left hand side, we will have a growth rate of exchange rate. But now, what do we have over here? Look, here we don't have alpha, so we actually expect alpha to be equal to 0. And over here, on this variable, we do not have coefficient. So we expect this coefficient to be 1. But of course, look, this is real world, not an economic model. So in the real world, we need to introduce disturbance term, and we expect actually for those values to deviate slightly, at least slightly, from expected values. Okay, and look, here we see the results. I didn't put here standard errors, but let me just say that here we've got a number that is negative, very close to 0, and actually it's characterized by relatively big standard error. So we cannot, it's indistinguishable from 0. Here on the other hand, what we see is 0.998, and if I remember correctly, a standard error here is 0.012, which is an amazing result. Also, R square in this case was also 98, 0.98, which we see that we get from this specification, from this result, that those two are actually very close. And look, the hypothesis that coefficient beta here is equal to 1 cannot be rejected. So what we see from this simple example is that within the period of 50 years, purchasing power parity, relative purchasing power parity holds remarkably well. Okay, now let's just also see this on the graph. So here we have a relative. Here we have this relative change in exchange rates and relative changes in price levels. So the inflation in some country J minus inflation in United States, and look, we are getting a straight line going basically through the origin. And here we see a lot of clustering of countries. And here you can see Turkey, Bolivia, Uruguay, Peru, and Argentina, uh, all countries that experienced periods of hyperinflation between 1960 and 2009. This is why they are over here. Okay, but look, what do we get from this example? That law of one price works remarkably well, but unfortunately, we only get from that we would have to wait 50 years for it to work. Well, no smart person is going to be predicting exchange rate 50 years from now. So now I want to show you my example that I made for you, in which I actually decided to take a little bit more complex, but not very much complicated, not very complicated perspective. Okay, so look, first thing I've done is that I collected the data on exchange rates and price levels in different countries. Now, I've collected this data from Penword table. So I'm using the data for period 1990-2017. But look, what you see over here is that I've chosen the data on 23 countries plus one United States, our reference country. And here you see independent floating. Look, this is one of the subjects we will be discussing very, very soon, and it's exchange rate regimes. Exchange rate regimes, of course, you know that there are floating exchange rates or flexible exchange rates, and there are fixed exchange rates. Now, those are theoretical concepts. In reality, everything is somewhere in between. And look, so of course, I would expect, and any rational person would expect, that the exchange rates for countries with fixed exchange rates are not going to fluctuate in such a way that is going to accommodate changes in price levels. So what I did do is that I went to IMF page, and the link to this page I'm leaving you in the description of the video. And what did I found in this page? Here is a classification of exchange rates from basically all the countries in the world. And look, what do you see over here? Here we are going from exchange rate agreements with no separate legal tender. So like when countries basically share the same currency, like the case of the euro area. As you see, this is a little bit outdated, but I will provide you links to the newer one also in the description of the video. And look, here we go from the most fixed exchange rate regime. We will be discussing this in details a little bit later, to the most flexible one. And look, 25 countries were classified by IMF as having independently floating exchange rates. Out of those, I took 24. I think there was no data on Somalia. Yeah, there was no data on Somalia, so I skipped it. But all the other countries, of course, I kept. Okay, let me go back to my presentation for a second. Okay, so what is the specification I've been estimating? Okay, look, it's very similar to the one that you saw in the previous part made by the author of the book. So look, I'm estimating growth rate of exchange rate as alpha plus beta times the difference in inflation levels between some country J and United States. Now look, so what is the main difference between what I did and what is and what is the what is has been done by the author? The key is that I didn't choose the period of 27 years, but I choose every possible 27 period. So look, I've estimated actually 27 different models like that. Here you have it noticed. So I always taken the exchange rate in year 1990 and price level in year 1990. This is the exchange rate against country J, a price level in country J, and price in United States in 1990. And look, then I was using, in my first regression, I used price level in 1991, P was equal to 1, then 92, 93, 94, until I got to year 2017. Like this type of estimation is called sometimes rolling window. In this case, maybe this is not a best description because actually here we have increasing window. But we are, I simply, look, this is still not a time series exercise, which means that I've been treating those events separately. Okay, so now, how did I do it? Look, the data that I used and the code that I used. Oh, let me just clear it so it's more surprising for us what we're gonna get. I'm gonna put in zasoby, of course, where you can download it and you can do it for yourself. You can make some changes. You'll see what happens, because actually the results surprised me quite a lot. Okay, and look, I use the library. Those are the three libraries you need to use in order to obtain my results. And look, what do I do over here? First, I loaded the data for prices. Then I loaded the data for exchange rates. Oh, here I needed to transpose them. And look, what am I doing over here is that let me give you an example. Like I'm doing here one model. This is for the last period. And here is the summary of this model. Let me just move it over here. Look, so here we see point estimate, which already gives you a little bit of a notion how amazingly it works. And here, this is point estimate for beta, and this is for alpha. So look, I got it using a function summary. This function gives you summary of linear model that we estimated in equation 10. Here, look, if this is for the 27th period, if I would like to do it for one first period, I would just change this to 1, 1. Then for second period, 2, 2. And look, out of this model, out of this object model, I can get different things. And look, here for example, I'm taking what? You need to first address it with two brackets 4, which means fourth element in the object. And this is like a matrix, and from this matrix, you simply take appropriate element. Okay, maybe let me show you this here. For example, summary model, and if I gotta put 4, I'm getting, you see, this matrix with different with 4 different positions. I was interested in coefficients A, B, those two. I was interested in standard errors, and I was interested in p-values. So those are the ones that I've taken. You can take more, but look, because I'm really, really lazy, of course, I'm not going to estimate 27 different models. Well, if you're gonna do it in eViews, of course now there is a possibility to use comment bar. You can do it even in EViews, but the smart way to do it is, of course, to use a loop. And look, this is how the loop is built in R. So you've got for I in 1 to 27. And look, here you put what at each loop the code should do. Look, it should estimate model SIPI. And look, first, in the first loop, it will the code is telling to put instead of I 1 and 1 over here, and over here and over here, everywhere here, until the end of the loop. Then it repeats the same thing, but now it substitutes 2, 2. And look, I estimated this way 27 models. I've taken out all those parameters and I put them inside these two objects. But look, for us, of course, the most important thing is coefficient beta. Whether coefficient beta, is equal to 1. And of course, how certain we can be of that. So I created this approximate confidence interval simply by subtracting 2 standard errors from beta and adding 2 standard errors to beta. Then I made out of this I made out of this a time series, and then I was able to create a graph over here. And look what I got. Let me just, for now, leave it over here. You're gonna get the code. You're gonna get the code on Zasoby, so you can use it as much as you can. You can check if there are no mistakes, because the outcome I got is something I definitely did not expect. But let's get back to the presentation. Here is the graph that I got. Look, of course, I've chosen the independent floating countries for a very simple reason. Because in those countries, governments intervenes the least on the exchange rate markets to establish some value of the currency. The currency has the most is the most prone to adjust to differences in price levels. And look, this is what we see over here. Look, this is value of the coefficient beta. We see that it deviates, of course, especially in the second year, quite a lot from, but only in relative terms. Look, here we've got 1.08 at most. Here we've got 0.91, the least. And it is in the first two periods. And look, basically, what you see over here, the green solid line is the value of the estimated coefficient. The shaded area is 95% confidence interval, approximate confidence interval over here. And I put, this dashed red line on one to see how it should be intact with theory predictions. And look, there are only few circumstances, one over here, actually three, one over here, and one over here, when 95% confidence interval is not covering 1. And look, the difference actually between estimated coefficient and predicted value are I don't want to say microscopic, but from the point of what I was expecting, it is microscopic. So look, actually, it turns out that with countries with where currency is independently floating, the relationship, relative PPP holds extremely, extremely well. But of course, look, I must say that I experimented with different price levels. Turns out that the price level that works the best is consumer price level. When I used GDP deflator, results were slightly worse for example. But I want to leave you with this, let's just say, optimistic case of how well PPP exchange rate, relative PPP, works in determining exchange rate in case of countries where currency is actually the closest to a purely flexible exchange rate. Okay, now let me just give you one more example. This is also an example from your book, and this example concerns hyperinflation. Look, going back to the formulation of our problem, what do we see? Look, if let's just say now country A is still United States, but country B is now Bolivia. Wait, am I right? Wait, this is Bolivia. Yeah. So Bolivia experienced a period of hyperinflation with inflation going above 100% in the period of a month, not a period of a year, a period of a month. So look, in this case, we see that if inflation in the United States is even 5%, which is rarely is, but even assuming 5% a year, then this expression becomes insignificant. And the only driving force of exchange rate between Bolivia and United States should be Bolivian inflation. And look, this is exactly what we see on this graph. Here is price level. This is a logarithmic scale, so you can see actually, you can read the growth rate of inflation from the slope, but you see how fast it was going. And look, this is the price level in logarithms in Bolivia, and this is pesos per United States dollar. And look, you see that those two graphs are almost parallel to one another, which actually shows us again that PPP condition works very well. And again, in cases of hyperinflation, like you see over here, it works basically immediately. Okay, so what have we learned now is that PPP, relative PPP condition, can be used very effectively to assess changes in exchange rates, especially in longer time horizons. We saw that it works to some extent even remarkably well. So now let's switch a topic slightly. Look, for now, when we were talking about exchange rates, we were only talking about nominal exchange rates. But especially in macroeconomic models, what is important is not nominal exchange rate, but real exchange rate. And look, what is real exchange rate? Look, to calculate real exchange rate, again, let's start with levels. We will denote it as QT. We take price level in United States. We multiply it, of course, by spot exchange rates, the same one before. So this is a price in pounds of purchasing $1 at time t. In order to take this price into British terms, and again, this is relative price of the two. These are relative prices expressed both in British pound. So look, before we were assuming that this is 1, but we no longer do. And before we say what is real exchange rate telling us, let's just go, of course, to the formulation logarithms. Look, again, if I take this expression, logarithmize it, I'm gonna, and what am I gonna get is that logarithm of of real exchange rate at time t is equal to logarithm of spot nominal exchange rate minus, now look, price in Britain minus price in price level in log of price level in Britain minus log of the price level in United States. And look, I hope in the at first sight it might surprise you, but look, minus and minus would give you plus, and here minus would stay. So as you see, all the connections over here are maintained. And look, again, I can first differentiate this entire equation, and I'm gonna get growth rates, a relationship between growth rate in real exchange rate, nominal exchange rate, and a difference in inflation rates in two countries. But look, postulated like this, what is actually real exchange rate? Look, real exchange rate that we see over here is a measure of a country's competitiveness. It is a measure of competitiveness because it shows where it is actually more profitable to buy goods. Look, let's go back here for a second. Look, this in principle is British real exchange rate because we calculated it for Britain. Look, we've taken British price level, which we have over here, and we have American price level, but expressed in British currency. Of course, knowing this, we can easily calculate. American real exchange rate. But look at all the information we get from this. Look, first, let's consider differences in inflation. In the first case, we see that if inflation in the United States is higher than inflation in Great Britain, while nominal exchange rate stays the same, then real exchange rate of Britain is increasing, which means that Britain is becoming more competitive. And it makes perfect sense because prices in the United States are getting higher, so it's better to buy goods in Britain. So, higher inflation in the USA causes decline in US competitiveness. And it works in opposite direction. If inflation is lower in United States than in Britain, while nominal exchange rate stays the same, then real exchange rate of Great Britain falls. So higher inflation in the UK causes decline in UK's competitiveness. Now, let's consider a situation when inflation rates in both countries are exactly the same. Let's go back for a second to formulation. Look, ST, the spot exchange rate, is price in pounds of purchasing $1. Now, if growth rate of exchange rate is negative in this case, it means that now we need to pay less pounds for 1 unit of American currency, right? So what we see over here is that even though prices are staying the same, then if you're a person that lives in Britain, you're gonna take exactly the same amount of pounds. You can buy more goods in the United States. So competitiveness of US economy has increased. But look, now this increase is not coming from inflation rate. It comes from the fact that nominal exchange rate has changed, and now goods in United States have become relatively cheaper. And look, it works the same case for British economy. Now, if I need to pay more pounds for 1 US, if I need to pay more pounds in for 1 US dollar, it means that if I live in Britain, then purchasing goods in Britain became for me more expensive. But person who lives in the United States thinks that now with the same amount of dollars I can buy more pounds. So using so now I can purchase more goods in UK, and ergo UK's economy has become more competitive. So as you see, depreciation of US currency or appreciation of British currency will uh, uh, will uh, will cause British competitiveness to go up. While depreciation of UK currency or appreciation in US currency, which of course remember are the same thing, will cause UK competitiveness to fall. Okay, but look, I hope that this moment you understand the entire idea behind real exchange rates. But look, we were stating that only for two countries, which is problematic. But look, we can calculate also effective exchange rates for some basket of currencies using usually trade shares as weights. You know, the more we trade with some countries, the more important they are to us. Then we can, and using information about inflation in these countries and nominal exchange rate, calculate real effective exchange rate. Look, because I was showing you the graphs of real effective exchange rate in the previous video, I'm not going to do it right now. And now we can focus on our final issue for today. So, causes of deviation from PPP. Now, the thing is, actually, it because when we started, I showed you the definition of law of one price, but this law of one price uh, actually demanded a lot of assumptions. For example, transaction costs. Look, we of course have transportation costs that we've discussed, and it's impossible to eliminate them completely. Look, imagine two marketplaces right next to another. Look, if we would have a situation that or that on look, think even simpler. There's one marketplace and there are two shops with potatoes uh, uh, with potatoes with potatoes on the opposite sides. And there is a guy who actually noticed that uh, on one side of the marketplace, potatoes, exactly the same potatoes, are 10% more expensive than on the other side. So, what should he do? He should, for example, buy the cheaper potatoes, stand next to the guy who sells more expensive potatoes, and of course, sell the potatoes cheaper. This is arbitrage, right? Now, transaction costs that are very often forbidding this type of behavior. Why? Right? Because if new company want to enter your market and wants to sell some products cheaper, tariffs, the fact that they need to deliver the products, they need to establish shops in the new market, they need to find the new contacts to suppliers in new country. It all costs money, and because of that, it will cause the differences in the prices between the two countries. The second thing is that when I was talking about potatoes, this is something when we can say the goods are very homogeneous. But of course, you have ecological potatoes, organic potatoes, and you have regular potatoes. Those are three different types of potatoes. We could treat them as different categories, but even potatoes from within one category from different producers can be different in their quality. So this is again a thing that causes deviations from purchasing power parity. Now, again, fixed investments and thresholds. So look, in case that I was telling you about the arbiter in the marketplace, it was really easy to buy some potatoes in a cheaper place and just go to the other part to of the market and sell the potatoes, right? And because of that, lowering the price on the entire market. Now, if you notice, for example, you're from Poland and you're noticing that price level, the price of some good you are selling, like let's just say bikes from our previous lecture, is lower in the in Germany, you can start selling cheaper bikes. But if the price difference is very little, it's probably not going to cover the transportation cost. But look, even if the transportation cost is covered, you need to establish a representation in Germany. So you need to make a shop, make contacts. Those are fixed investments that you're not gonna get them back, and this means that there is a threshold that the price difference between the two countries needs to be big enough. So if we actually make an investment, if we actually make an investment in a different country, we will make a profit, and this profit can cover this fixed investment and can be sustained over the longer period of time. Then we've got non-traded goods. Look, there are some goods that we simply cannot trade, like going to a barber, or visiting a museum, right? Of course, museums are different in different countries, but we can expect also that a museum of locomotives that would be exactly the same in Great Britain will have a different price than museum of locomotives in Poland. So some goods are not, because some goods are not traded, they can create further deviations from PPP. Look, the formal proof of that is shown in something called Balassa-Samuelson effect that we're going to discuss in more detail in the future. Finally, there are composition issues. Look, those composition issues are simply related to the fact that price indexes are constructed in different ways in different countries. You know, people in different countries have different preferences. They also have different income structure, so they purchase different goods. So when governmental agencies are actually calculating the price indexes, they use different weights. Okay, so this is it about PPP. Next time we're gonna discuss another force behind interest rate, more of a short run, medium run force that is called interest rate parity. Okay, thank you for your attention and see you in the next video.